Good morning, professors. Welcome to this novel and exciting experience with the Science Bus. Today we shall be discussing measuring instruments for length, including the meter and the caliper, as well as the intricacies of measurement errors. It is an experience that is well suited for high school students, and in order to conduct it, we require the mechanics kit. In the international system of units, the instrument that is employed for the purpose of measuring length is the meter. The meter that is supplied has a range extending up to 2 meters and a sensitivity of precisely 1 millimeter. However, when it becomes essential to measure smaller sized objects, especially when we intend to determine the depth, thickness, or internal diameter of a hollow object, it is beneficial to make use of the caliper. The one that is supplied possesses a range that extends up to 15 centimeters and a sensitivity of precisely 1/10 of a millimeter. Allow us to continue elaborating on the various components of a caliper. This comprises a stationary rod, which serves as the graduated scale, a movable rod referred to as the vernier, the jaws, 2 nibs, and ultimately a depth rod. The stationary rod of the caliper is equipped with a graduated scale that is precisely marked in centimeters. On the lower section, you will notice the movable component, which is referred to as the vernier, and it is marked in millimeters. On the upper section, there is also a vernier marked in inches, but we do not need it for our specific measurements. The vernier is essential because it allows measurements with a precision of 1/10 and even 1/100th of a millimeter. The jaws are utilized to measure the diameter of hollow objects. The jaws are employed to measure the external thickness of various objects. Ultimately, the depth rod is utilized to measure the depth of an object when there is a hole present. Let us carefully observe how to effectively utilize it in a practical application. We proceed by selecting the wooden cart, which is a parallelepiped shape, and we aim to accurately measure its thickness. We securely position the object between the jaws and meticulously slide them until they are in firm, unyielding contact with the sides of the parallelepiped. To accurately measure the thickness in both centimeters and millimeters, it is of utmost importance to observe what the 0 on the vernier indicates in relation to the fixed graduated scale. In our specific situation, we observe that the 0 on the vernier has exceeded 4 centimeters and an additional 2 millimeters. Therefore, the thickness of the wooden parallelepiped will be exactly 4.20 millimeters. Now, let us proceed to ascertain the tenths of a millimeter with a high level of precision. To accurately determine the tenths of a millimeter, it is absolutely essential to carefully observe the specific point on both the fixed and movable scales where the markings align precisely. In our particular case, we observe that the alignment of the marks between the fixed graduated bar and the movable component of the vernier coincides at the number 6. Consequently, we can confidently conclude that the thickness of the wooden parallelepiped is precisely 4.26 millimeters. Let us now proceed to understand how to utilize the caliper for the purpose of measuring the depth of an object that contains a hole. We carefully insert the depth rod into the hole, ensuring that the caliper remains perfectly perpendicular to the object. We gradually open the jaws until we can discern that the rod has made contact with the bottom surface. At this juncture, we carefully remove the caliper and proceed to meticulously observe the measurement obtained, following precisely the same method as previously described. Ultimately, let us advance to thoroughly comprehend how to effectively employ the caliper for the explicit purpose of accurately measuring the interior diameter of a hollow object, specifically the glass beaker. We carefully insert the 2 jaws of the caliper inside the container and gradually open the arms until the jaws have adhered securely to the walls. At this precise point, we gently remove the caliper and meticulously observe the measurement as we did previously, calculating the centimeters, millimeters, and tenths of a millimeter using the fixed graduated scale and the movable vernier. Following this series of direct measurements we have taken, we will now explore an indirect measurement, such as calculating the volume of the parallelepiped and the mass of the cylindrical shape. Let us advance by meticulously determining the thickness, height, and length of the wooden parallelepiped with the utilization of the caliper. Subsequently, we proceed to thoroughly compute its overall volume. Once again, we acquire the precise measurements of the dimensions of the wooden parallelepiped utilizing the ruler. We ascertain the length, height, and depth, and once more determine the volume of the parallelepiped, carefully noting the discrepancy observed from the results derived through the measurements taken with both the caliper and the ruler. Now we are advancing to meticulously compute the overall volume of this cylindrical mass. By utilizing the caliper, we shall precisely measure the dimensions of the external diameter and the height of this specific cylinder. In this manner, we shall be able to accurately compute the overall volume. We acquire the precise measurements of the height and the diameter of the base by also employing the meter, and we shall once more compute the overall volume of the cylindrical mass, carefully observing the result obtained and subsequently noting the difference between the two. We conclude by stating that it is crucial for the purposes of this particular experiment to thoroughly evaluate the measurement errors that may occur. This is mainly attributable to the fact that we wish for the measurement to be both extremely accurate and precise. Consequently, we must consider the absolute error, which represents the discrepancy between the true value and the measured value. In this way, the absolute uncertainty, denoted as delta x, will allow us to determine a particular interval within which the true value of the measured quantity is most likely to be found. As a result, to guarantee the highest level of accuracy and precision, the measurements are meticulously conducted repeatedly on numerous occasions. This repetition allows us to determine the mean value of all the measurements obtained and to calculate the relative error, which is characterized as the ratio between the absolute error and the average value of the measurements acquired. Professors, thank you. We will see each other at the next experiment.